Hello, this is the video for Lesson 1, Topic 1, where we're going to talk about, we're going to begin our journey getting into the wonderful world of Cisco. So, under Lessons, I'll go to Student Preview mode. Under Lessons, Lesson 1, Topic 1, Culture and History. So, again, the whole point of this topic is to kind of pretend like we're Cisco engineers, right? You gotta walk the walk and talk the talk. So, same thing. We need to get in the mindset of a Cisco technician, and therefore we need to know how and why Cisco acts the way it does. Here's the terminology, which I will be talking about as I go through the course, through the talk, and some of these are some of the concepts that we'll be talking about. So I'm going to click on this and go right into my slides. And let me hit present. And I'll bring up the pointer. There we go. Looks a little bit better. Ooh, RAM is not happy. Wow. Okay. Something caught up there. All right. So let's get started. Quick history of Cisco. Started by a husband-wife team to build a multi-protocol routers in the early 80s. It was based out of San Francisco, so that's where the term Cisco comes. And if you look at the logo, it's essentially the San Francisco, the Golden Gate Bridge, just with bars. So, interesting debate if the company was truly innovative or in the right place at the right time. They were there at the birth of the internet, of WAN networks. So they were just so happened to be the cutting edge company that was building top-end routers at the time when people were spending a lot of money on infrastructure for the internet. So you'll hear that circle. The Cisco haters will just simply say, they were there at the right time, the right place. But in any case, they're directly tied to the rise of the internet, and they have the majority of the routing infrastructure and the switching infrastructure of the internet since the beginning, and they'll be hard to displace, although there are companies of doing their best to do so. When it comes to innovation, what they tend to do is they tend to buy new things. Case in point, their wireless technology. I'm trying to remember, Tsunami, I believe it was the name of the company. Yeah, they bought Tsunami in the late 90s, maybe early 2000s. I think more late 90s. But they bought, in order to go into the wireless technology field, they saw wireless was going to be a place where new networking was going to come in, and so what they do, they just bought, what technology they saw as available, and that was good. Okay, they usually don't buy the best technology. Another good example is Firewalls. Actually, I don't know the name of the firewall company they bought, but if we look at the operating system of a firewall, it's not true iOS, and that's because that firewall was actually bought by them, and they've slowly started to turn it into iOS. But anyway, Cisco tends to acquisition themselves into new markets. They don't truly build things from the beginning. They don't bring anything from the ground root up. The only core technologies they've bought from the ground root up is their iOS routing technologies, Catalyst switching technologies, and now the Nexus, which is core switching. So we'll talk about that in a second. Recently, we've seen some declines with Cisco, primarily in foreign markets, and that's because they kind of were caught playing ball with the NSA a little too much, and foreign markets are none too happy about that. They are still strong at the core of the internet itself. Again, like I said, they've had market share, and market share in the United States, last I checked, was somewhere around 70%. Back in the 90s, it was in the 80%. In Europe, again, like I said, we're seeing decline in market. Last I saw was like 60-something, 61, 62% of the market in Europe. China, even lower. So there are some recent declines. There are companies that are taking the two biggest competitors are Juniper, which actually, interestingly, is the Cadillac of Cisco. They actually build more expensive, more feature-rich products of Cisco. They were actually started by Cisco engineers, and cul&his essentially is a upsell of Cisco, and so they've been taking some market share away from Cisco from the upper end. And on the lower end, they've been getting attacked by primarily HP ProCurve services, offering switches. Lots of people offer switches nowadays that do all the things that you need them to do. They can do VLANs, power over Ethernet. But like the other features that we'll be talking about when it comes to iOS, HP ProCurves can be just as feature-rich as Cisco devices, and they tend to be a bunch cheaper. Anyway, I've looked at HPs in my various businesses I've worked for them before, and I've actually worked on HPs, and they're not bad products. Anyway, so they do take a bit of the market share. I do prefer Cisco. I could be talked into Juniper. Those are really good products. So anyway, that's the current situation with Cisco. All right. So let's talk about their 3-layer approach. Okay, Cisco is interested in their network model. All right, they have their own network model. It's more of a design conceptual model than it is an actual network model. We talked about in the precursor. We talked about the OSI, the DoD, and the TCP/IP models. Those are more for understanding theoretical what's going on behind the scenes of the network. This is more a design concept, I would say. All right, so we have the access layer. So this is on the edge, right? We're going to be going circles here, right? Here's the picture right here. It's on the next one, so we'll get to it. But the access layer is the edge network, right? That's where our users are actually going to plug into it, okay? We can do things like we can do some security with 802.1x, with port security. This is where we can have VLANs at the port. Okay, so this is where our users are going to actually plug into the layer. That's why it's called the access layer, right? Sorry, switched over by accident. Next one is distribution layer. That's where we're going to do routing. We can do network management, network traffic, quality QoS. This is where we actually make decisions on traffic. This is where it's okay if we slow it down a little bit because we got to make smart decisions on where this is going to go. So the whole point of the distribution layer is to intelligently route the traffic logically. Okay, that would be the distribution layer. All right, and then we got the core layer. All right, the core layer is at the very core, the backbone. Right, we talked about backbone in previous networking classes. Right, this is the high-speed core of the network. Okay, the idea here is not to do any of the stuff at the distribution layer. Right, no routing, nothing, no natting, nothing that's going to take time or add latency to the traffic. This is going to be as fast as humanly possible. So that's the core layer. Okay, so this is what it looks like in the drawing. At least my version of it. At the access layer, we have at the edge, right? This is where here's access layer. We have switch with VLANs, port security, QoS, PoE, right? We got our voice over IP phone. We have our laptop. Fantastic, right? The distribution layer, that's where we have our router. Okay, router with access control list, policy-based routing, which we'll get into when we talk about advanced features and routers. But essentially, policy-based routing, I can route traffic based off an access list. So I can sit there and say, oh, if you're that IP address, you go here. If you're that IP address, you go to this router, right? So that's policy-based routing. And QoS, quality of service. All these things, NAT, I can think of other things too. Network address translation, anything that's going to slow down traffic where it has to get entered into a database or calculations or scrubbing the data, changing the IP address like we do with NAT. That's going to happen at the distribution layer, okay? And that's because it does slow down traffic, right? That's the whole point. At the core, fast. It's just switching, right? Hardware switching, packet pumping, as I like to call it, right? It's just moving packets from one port to another port as quickly as humanly possible, right? That's the core layer, all right? That is the Cisco hierarchical model. I have the full definitions here, and back in the topic up here in the definitions, I have a more succinct, much more succinct definitions. Okay, so let's get back. All right. Cisco Certification. Let's look at the Cisco's website because it's ever changing, unfortunately. So essentially there's, and they don't really do a great job of, here you go, here's a good one. So we have the entry level stuff, the CCENT, that's meant for like help desk support, assistant technicians, lower technicians, that type of thing. All right, you're beginning off in the industry. A lot of people skip right away to a CCNA. They are going to combine. They got rid of the flat CCNA, Cisco Certified Network Associate. So with a CCNA, you can do some administration. A lot of places, Stick here, for example, will be happy to have a CCNA on staff to be the network administrator. Matter of fact, they're having a hard time finding that right now. So anyway, now again, what happened was they got rid of just the CCNA, and they had specializations. Now they're going to have there is going to be a general back. They're going back to the old model of having a general CCNA, but then you can get these specializations on top. Routing and switching is the most popular one. I've had the security. I flirted with getting a wireless, but anyway, point is, these specializations just kind of let you know what your specialty is. All right. And this is the true level. Again, a lot of places will be happy with this as their administrator, especially mid-size, good-sized companies, right? So the general CCNA is coming back out. I do have some of the definitions here. Assistant job, entry level job. It's kind of in there, right? Not trying to make it too difficult. CCDA is also in here. That's a Cisco Certified Design Associate. So every single layer is going to have its own design version. Okay, that means this is for administration, and this is for design. Okay, this is help associate level design, so smaller networks, LANs, that type of stuff. At the professional level, again, it's the CCNP. I'm not sure if they're bringing back just the general CCNP, but CCNP is going to be your certified network professional. Again, that is kind of obviously a higher level. It's more general as far as what you can do and not do. Anyway. And then we have a Cisco Certified Design Professional, a step up from the Design Associate. There's also the expert layer. This is tough. Again, one of the things, obviously everyone when they first join the industry is gung-ho, is like, I'm going to get my CCIE. For the most part, that's a really tough test to take. Again, not impossible, just really, 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 really hard. And everyone that I've ever met, at the very least, knows their stuff. They're very well studied. Most CCIEs I met are really impressive in their deep knowledge and have lots of hands-on with Cisco. It's a two-part test. You have to take it both in the classroom and in the lab. You have to drive to a lab environment. I think there's one near Boston, in Boxborough, that you can sit in a lab environment, and you actually have to get things up and running. So anyway, Cisco Certified Internet Network Expert, CCIE. Again, there's specializations as well. All right. That's really what I wanted to say. A lot of people are always curious on what level, and should they bother with the CCNE, the entry level. I really wouldn't. I wouldn't do the CCENT. If your goal is to get a CCNA, then just go right for the CCNA. All right. And the one that I started off my career with was just the general CCNA without the specialty. Second one I ended up getting was routing and switching, and I also ended up with a security as well. But again, that was just for specialized jobs, and you'll see the jobs that do offer that do require CCNA. So there you go. All right. Again, and that's ever changing, so that's a moving target. But I do have some general definitions up here, just so you can have something to memorize. All right. All right. Let's keep moving. What is so let's move on to Cisco Ios, right? This is the core of it. What is Ios? Originally an Inter-Network Operating System in 1986. It's essentially a CLI. There is some GUI On newer models, like switches, there's a web interface, but at the end, that GUI is just generating the CLI in the background. Most experts use the CLI. They go right into the CLI. We're not. Matter of fact, I hate it when people touch my switches or my routers with the GUI because it added a bunch of commands I didn't like. So I tended always to go right into the CLI. Except for the firewall. The firewall, there's reasons for that. But anyway, when it comes to routers and switches, I always went in right directly in the CLI. There's a common kernel for all, although, again, Knox OS is a little different. There's a common, and also like firewalls and their wireless controllers and wireless devices, but a common kernel for all Cisco devices, all switches and routers, not including Knox OS. Really just most routers and some switches. Other devices have either homegrown OSs, NXOS, Knox OS as it's sometimes called, or morphed from other companies' OSs. So remember, Cisco grows through acquisition. Great point in this is the firewall, which they call Finesse, apparently, Finesso. It's essentially, it was the original operating system of whatever firewall company they bought. I can't remember the name of it. This was going back to the 90s, but essentially over every single release, it's become more iOS-like, right? They turn this company's code more into iOS as it's gone through. It's still not 100% iOS, and never probably will be, but it's close, all right? There was, the concept was back in the 80s and early 90s was to have a common kernel for all Cisco devices, but business acquisitions intervene. So one important concept is versions. Unfortunately, and I do have this. Let me escape out. I do have running in the background GNS3 with a switch running. We'll open up a console. Here I am in a switch. If I do a show version, we're not going to get it's a simulation really, and we're not going to get a full train here. As you can see, the version is 15.1 and then a rather large number. I think that's the license because this is a simulated. 15.1.b. Anyway, so if you did that to a real Cisco device, you'd get a much more specific answer. But so you would get something that looks like this: 12.4 Z4 T7. What does all this mean? And this is kind of your introduction to Cisco for engineers by engineers, okay? So the first number is the major release, that's 12. 0.4 is the minor, okay? So you got the major, right? Minor release. We have what's called the throttle, okay, which in this case is Z4 or 24, I guess. And yeah, the way they did their twos is look like Z, so that's actually 24. I'm sorry, so throttle's 24, and then we have a rebuild, which is the 7. Okay, now T here is actually part of the train. All right, this is the way it works. So the train is where the foundation of iOS set is established. So it's what features it has, who's it's built for, okay? So common trains, we have M for mainline. Most of the time you'll see on mainline, all right? T is technology, that's bleeding edge stuff. A lot of people stay away from that unless it's like a test setup, an experimental setup. People tend, or there's a feature you really, really need, but most of the time you try to stay away with it because there tends to be more errors in that code and more problematic code in it, right? We have service S is for service providers. They're built for stability and traffic manager feature sets, right? That's for core, the Verizons, the QS of the world, right? E is enterprise. That's for uptime. It's completely built for uptime. And then B is broadband. There's a broadband feature set. That's for obviously cable companies, endpoint, last mile companies. And there's X, which is for special feature sets, right? Most of the time, I've always spent my time on mainline, which is just kind of everything's been tested and retested. It's been out for a while, so mainline, and then once in a while enterprise as well, if I can get the license for it. So there you go. Which has some of the newer technologies before it goes to mainline, but they are guaranteed to stay up. So those were always the two trains I always worked with. But so there you go. So you got your 12.4 In this case, it's a technology. That's the train. Okay. A throttle is roughly a minor version. There's some new features, new bugs. Mainly just bug fixes have been added. So in this case, they have 24 different releases of 12.4. 12.4 would be around for a couple, 2-3 years, right? So there might be 24 updates they've done to that code to either add features or more likely bug fixes. And then there's rebuild, which is more bug fixes. That's if they don't want to change the throttle. So here's this is where I get the information, Cisco's cheat page, and then here's a download page to give you an idea of what it looks like. So if I was to grab like a switch, and let's just grab not a Nexus. All right, here, Catalyst 20X series, yeah, or 2960X series. We'll grab a 24. We'll grab a 48 porter -L. All right. So if I click on downloads, I can see right now currently they have 15.27 E1. So again, it's a 15.2 is the and it's an enterprise train. Okay. And then 7 would be how many revisions they've done, and this is the first. This 1 would be this is revision 1. 7 would be the throttle. So they've throttled it 7 times. So they throttled the train 7 times. They've added features or changed bugs or fixed bugs, and they've of those 7 throttles with the 0.7 throttling. This is the first release. Okay. So that's how it works. I know it's a bit confusing, and it seems unnecessarily complex, but I hate to break it to you, but that's kind of how Cisco operates. Is all this complication really necessary? And it's done somewhat intelligently, so you don't mind, but it's like dealing with a kind of a mad genius at times, right? All right, so where does iOS live, right? If we have iOS and it's on a switch or a router, where does it live? And how do we upgrade it? Well, remember, these devices tend to be can be at the core of a network. They can be in the edge. If they go down, we can have a whole building go down, right? The whole building of users can be going down. So uptime is very critical to most Cisco devices. So when you do a upgrade, when do you need a reboot? Major versions, from my experience, almost always require a reboot. Minor revisions, sometimes they need a reboot, and for releases, almost never. Right? It would have to be a really like a security patch that's critical on a release. Okay, so if I was going from the previous slide, 12.4, which is quite old, we're up to 15. So if I was like 12.4 and I was going from 12.4 to 12.5, right? I would probably expect that not to cause a reboot. Maybe it would, maybe it wouldn't. It'd be in the documentation, be in the README. However, if there's a new release coming out, a new rebuild, right? So they were going from T7 to T8 to rebuild number 8 on 12.4T. Then I can bank that would not cause a reboot. Okay. Sometimes on a throttle, because if there's a new feature add, sometimes it requires a reboot. Again, that's going to be in the README, and you got to read through it carefully. There has been times where I haven't read through it carefully enough, and particularly because you're going from one version to another version, so the rules change depending on what version you're coming from, upgrade paths. And Cisco can be a little complicated with what's called an upgrade path, where you go from, like, say we're going from, say we had an old switch running 12.4 and we wanted to get to the latest, to a newer one like 15.3. We might actually have to go from 12.4 to, might have to make multiple stops, like a plane crossing the nation, right? We might have to go from 12.4 to 14.1 and then from 14.1 to 15.5, right? There's been times where I've had to downgrade. I've had, say I wanted to go from 12, I wanted to go to 13.5. I would have to go to 12.1, then go to 13.5, right? So I'd actually have to downgrade a switch and then upgrade it to 15. That's called the upgrade path, and that can be painful. All right. Big important concept is where iOS lives. We have EEPROM flash, sometimes TFTP server, which is very odd. So iOS is going to live, and here it is right here. Let's bring it up on my switch. Which, oh, actually, I can just click on this. There you go. So if I do a dir flash, uh-oh, that's not good. It doesn't like it. I need to do a der. Okay, flash. There's NVRAM. I guess these simulated ones don't have flash. I don't think it's system. No, that's the running config. That's my memory. Let's try disk 0 for some reason. We'll do 1. Yeah, nothing. All right. So it's being weird. A lot of times you can, on a real device, you can do dir flash, and you can actually see the operating system. I'm curious where the operating system is living then. Whoops, sorry, I hit the mic. Probably got a pop. I'm sorry about that. So let's do a show version. Yeah, all right. It's coming right off the hard drive, so it doesn't load it off flash in the case of the simulated switch. It's loading it off the hard drive. So right here, this is their version of flash. This bin file, which is the actual operating system. It's the binary of the operating system. Usually runs in out of flash, out of the EEPROM. Okay, that's where iOS lives. So when you need to upgrade the operating system, you often have to copy it over to flash memory. Okay, remember EEPROM, electronically erasable read-only memory, right? So it's special memory that will not lose its, as long as the battery is good on the motherboard, will not lose what's on that memory because it's fed by a battery. And that's where the operating system reads, okay? Or comes off of. It gets decompressed, actually. It's compressed on there. And then it's loaded into RAM, okay? So these devices have RAM, flash memory, and they also have non-volatile RAM, and that we'll talk about that in a second, all right? So again, iOS lives on this flash, the EEPROM, as we often call it, flash memory, and then it gets decompressed from flash memory and loaded into memory when it first boots up. That's the boot up process, okay? Which I'm not sure if we'll be able to see here if I do a reload. But that's what it looks like. It usually has to uncompress it for the operating system, and then it brings it up. It's not that dramatic. So there you go. So iOS lives on EEPROM flash. Sometimes you can have it run off a TFTP server. I've seen it. It's very odd. Some people like it though. You can more centrally manage your operating systems. Of course, TFTP has huge security problems, but there you go. But we'll keep bumping into that because we love our TFTP. All right. So what is the boot up process? We have what's called post, which is the initialization of the hardware. It runs from ROM, read-only memory. It loads up the bootstrap from ROM. Sometimes we call that ROMmon, which is, again, part of your definitions here. ROMmon is right up here. So ROMmon, right? That's going to be the bootstrap. You can, if you hit break, the break sequence while it's coming up, you can get into ROMmon, which is that way you can change the config register, which we'll talk about in a second. The ROMmon then loads up, takes the flash that lives in iOS, so it's compressed, and depending on the config register, knows what to do with it. Okay, if the config, well, it loads the flash into the memory, right? If the config register says it's okay to load into memory, it'll load into memory and it'll start loading up iOS. Okay, some other things. The most important thing the config register also tells it is whether or not to load up. There's going to be two configs. There's a running config and there's a startup config. Okay, the startup config lives in NVRAM. That's short for non-volatile RAM. Okay, that is the file, and this does exist in the simulator, so we can get back to that. Wrong command console. So if I do I have to actually first do something to make a change. So I'm going to change the host name. This is what you'll be doing in the lab. I'll just change it to JJH, switch 1, changing the host name. And now I'm going to copy the running config. So currently there's a running config, right? That's what I just changed. And this is the command I just changed right here. Host name, JJA SW1. Okay, that's what I just changed. All right, if I do a show start, right, it's going to have the old host name in there, right? Because I hadn't changed it. It hasn't been saved to the startup config. But the running config, it is running, and that's what I currently have. So running is your current state. Startup's the state you're going to load up when you first boot up. Okay. Now, if I do a copy run start, running config. By the way, I'm tabbing out. We'll talk about that in a sec. Starting config, right? It's going to ask for the file definition or the file name. Startup config is what I want. I hit enter. This. Do you want to write the previous version? Yes. Okay. Now I've written it. If I do a dir flash. Oh, not flash, but NVRAM. Sorry. There I go. There's my startup config. It's 876 bits. Okay, so there's the startup config. And if now I do a show run, right, which is short for show running config, you can see my host name is now JJSW1, and if I do a show start, it's going to be the same. Show starting config, startup config, and it's now the same because I copied the one config and running from RAM over to NVRAM. All right. Now the config register, what that does is it's essentially a 16-bit software register that's written in NVRAM. So it's a small little tiny file. It's 16 bits, right? And what it does, it tells the router how to boot up. All right. So by default, iOS from flash, startup config from NVRAM. Okay. However, it looks like it has 0x, right? That indicates that it's hexadecimal. I'll go to presentation mode. The 0x right here, and I'll bring up the pointer. This 0x2102, that is the config register. Okay, that's what it looks like. This indicates it's hexadecimal. The zero. Sorry, I hit the button. The 0x21 or the 0x into hexadecimal, and these are all hexadecimal characters. Okay, so 0x equals hex. So four bits for every single one, right? 13, 8, and 1 on if bits listed 15 through 16. All right. So the important thing is this. The 6-bit, which is the 7th position, is setting for iOS not to load for startup config. So by default, we have 0x2102. Just know that 2102 is the default. 0x2102 is the default. 0x2142, so just remember we got double the number, 2142, right? So this is the 6-bit. If we turn the 6-bit on, what it does is it tells it not to load the startup config from the NVRAM, okay? Which is really important because that's where it loads up passwords, okay? So if I hit, and I can change the config register from the bootstrap. So I can boot to the bootstrap, change the config register, boot up the router without a startup config, and therefore no security, no passwords whatsoever. Okay. If you physically possess a Cisco device, you can reconfigure that Cisco device. I can get in software-wise. Okay. You can must change register in iOS, or you can do it from the ROM mod. Okay, so this is must change it back. Essentially, that's what that should say. Okay, you must change it back from. Otherwise, no matter what changes you do make, won't take apply every time you come up with a blank slate, unless you change this back from 2142 to 2102. All right. Again, we've talked a lot about this with startup and startup versus running config. Startup lives in NVRAM and by default is loaded by iOS when booting. Essentially, a startup script. So running the running config lives in RAM or DRAM, dynamic RAM, which goes away when the power goes out. When the power goes out, RAM is blanked out, right? When the config has been changed and you want to save the backup off a reboot, then type copy running config or startup config. Okay. The break command, often it's control break, or sometimes it's control shift 6, then B during routing, during the router boot up. The switches you can hold a button. Often you have to hit the button to send the break command. It puts you in what's called ROM monitor mode, or ROMmon for short. In ROMmon, we can load up new iOSs to the flash. We can change a config register. We can run some memory diagnostics, that type of thing. Okay. Understanding many modes of iOS. All right, so we're going to have, let's see if I can bring this up at the same time I bring up the, so I'm going to bring it over here, and I'm going to switch over to that workstation. Let's see if we can do this. All right, so different modes. Okay, right now I am in enable mode. Because there was no password set on this, so if I went in and I just did config T, I did not make a copy when I opened this up. I'm okay. Well, that's all right. So I won't save this. So if I do enable pass, I'm going to set a password real quick to SW1. There I go. I made the password. So if I do an exit now, it's still putting me right into enable mode, which is interesting.
Nice party.
Oh,
Nice
so if I put it into enable mode, then all right. So there you go. So if you have the caret, let's see, greater than symbol, then that is you are in user exec mode or user mode. Primarily used to view statistics. You can't do much configurations to it. You can't view the starting config or the running config. That's where you have to do it from here, from the enabled mode. Okay, that's what we call this often with the pound sign is enable mode. It's all the proper name is privileged mode, but everyone just calls it enable mode. The way you get to it when you first log into a device, if you only have this, is you type enable and EN short for enable. Sorry, you type in enable and and then you go into privilege mode. That's why most of us call it enabled mode. But there you go, switch enable, and then you get the switch pound sign. Use to view configurations. You make some changes to the firewall, or you make some changes to the devices. You could do some more things, but for the most time, as you saw me right there when I entered the password, I have to go into config mode, all right, which is the next one we're going to talk about. I might hit present. Let's see if I can tab. I'll tab over to that. There we go. Let's see. Oh, that's awesome. All right. So, configuration mode, what you want to do to get into it is you go configure terminal is the full term, right? Or you can just hit config T, but config terminal, all right, is the proper full size term. It just what you're doing there is you're telling it where you want to configure from. So if I did configuration, configure, and I did a question mark here, I can configure them just the NV memory, right? So I can make changes just to the memory, right? Or I can go through the terminal and make changes in config mode, which is what we're going to do most of the time. So configure terminal, right? And that puts us in config mode. All right. So it's used to make global changes to running config, like in this case right here. I changed the host name, what I've showed you already, and I've put an enable pass on there, right? So if I do an exit and I do a show run, that password command is now in there. As you can see, that's all the startup command is essentially a script, right? And so things that I'm typing into the config go in there. Enable password SW1. All right. We'll talk about passwords and how to make them a little bit more secure than that in a bit. But anyway, but notice also I had to dump out to do the show run, but because if I'm in config mode and I do a show run here, no likey, right? Now what I can do is there's a do command, and if I do, it's going to run it as if it's in enable mode, so then I can do a do show run. All right. So that way you can save yourself the hassle of going back down, which I can use the exit command to go back down to enable mode, and then I have to sit there going back into config mode. All right. So in every single mode, you can do different things, and you need to know what mode you're currently in. Now, the way I know I'm in config mode is I have the config with the prompt, right? So I'm in config mode. All right. Now, if I want to make a change to one of these interfaces, here's interface 00, right? I can go into int Ethernet 00, right? And then I can do things like this is a switch, so I'll change its access. Well, we don't have any VLAN set up, but I'll change its. I'll put a description on it. So I go description test, right? So now I've put a description called test. If I do a do show run now, do show run, right? I go down to test. Or go down to 00, it now has a description of test. Okay, if I try to do that like here and I say, hey, int 00 or Ethernet 00. By the way, that E stands for Ethernet. So if I do interface, the full command, I gotta keep remembering to type out the full command so you guys don't get confused. Interface 00 is what I'm saying, right? So there's just in Cisco world, I can type out the beginning of a command as long as it's unique. So like pasting int, if I do an I and then a question mark, right? These I can't say just do I and then Ethernet 00. I can't tab that out. That pink that you're hearing is saying no, you can't do that, right? If I do I Ethernet 00, it ain't gonna work, right? Because it doesn't know what I is. There's 6 commands here that does I, right? So if I do but once I do int makes it unique. Actually, IN, really. I could just get away with IN with this simulated one. Real switches, I think, have other commands that I've never been able to do IN. So, but I can also tab it out. That's what I've been doing right here. So the moment it's unique, I can tab it out, and it'll fill it out for me. Or I can just simply say internet, and then E makes that universal, because if I go down and hit a question mark here, if you notice, there's a bunch of different interfaces. A lot of these are just stuff that you'll never get into. VLANs we'll get into, but if you notice, there's only there's a couple E's, but it just assumes Ethernet because, again, welcome to Cisco. Somewhere along the way, someone said, we don't want to type out ET every time for Ethernet. Just take it on an E. If I do an E, notice tab won't work here, but yeah, if I do ET00, it will work. It'll get me into Ethernet 00. Sometimes Cisco just holds on to old things, all right? Notice I'm exiting to go back out. I can also do, so if I go interface, right, I'll do int because that's what I'm used to. Int 00. A lot of this stuff is muscle memory for me. For 15 years, I've been in iOS doing things. A lot of this is muscle memory. But if I go in that interface, if I hit Control Z, by the way, it's going to dump me right back to enable mode. This pops up right here. This is a syslog message that pops up and tells me that someone in the console configured it, and it gives me a time date stamp. Okay, and that goes into the syslog, which we'll talk about later in this course. All right. So again, I can go into an interface. So if I go config T, and I go internet ether 00. All right, I can then make changes. So description test 2. All right, and now if I do a do show run, if I go to internet Ethernet 00, there it is. Test 2 is in there. Okay, so that's config, and we know it because we have config if. Think of interface. That's why it's if. Config if lets me know I'm interface mode. There's some other modes I need to know. There's line mode. So right now it gets a little weird because we're doing the simulator, but in the real world there's a couple ways you communicate with a switch. Okay, there's a console port in the back, and then there's a line, and then there's telnet or SSH. Okay, that's what these are right here. VTY is virtual. It's for telnet. Okay, that's where there's not 15 of them. And right now, this says you have to log in with TTY. That's interesting. I guess I'm in with console right here. And so what this does, so these are the line modes, right? For what we need to know is I need to go config T, and then I can, instead of going to interface, I go to line, and then like I do console 0. See, if I do CON, that's fine. but if I tab it out, it's console. And there's only one console line, console 0, right? Zero-based numbering of lines, okay? And then I can make changes here if I wanted to. If I hit a question mark, it's going to show me all the commands I can do here, session timeout, that kind of thing, all right? Let's exit back out, go to a different line. If I go to line VTY, I can go line VTY, like the very first VTY line, require a login, second one not require a login. Why you would do that, I don't know, but you can. Or you could just do them all together. Interestingly, most places do, most switches, real world switches do VTY 0 to 15. You're allowed up to 16 people connected to a switch at one time. This one, it looks like there's only 5, which is interesting. So if I do VTY 0 and I do a question mark, 4, yeah, I can do up to 5. I mean, it's not a big deal. Just interesting with this simulator why they do things like that. Probably to save memory. Anyway, so line VTY 04. What I'm doing is I'm making a change to all those lines, right? I don't think there's a description in this. No. So I don't want to make any changes to show it, but that would then show up in the do show run, the line section of the config right down here. Okay, so there's line con 0. Auxiliary, that's weird. Why would a switch have an auxiliary? But that's usually for a dial-in connection in the back. And then we got line VTY 04. Okay, so there's in this device, there's 3 different lines. Most switches in the real world will only have con and VTY. VTY, you can also, through these commands, enforce it to be encrypted. In other words, do a SSH connection. All right, so telnet SSH. There's also other modes. If I want to make an access list, hopefully this simulator will let me do an access list. It might not. I should do that in a router. I'm going to do access list. Let's see. Oh, we're good. Access list. In this case, we're just going to do standard. What can I do here? Okay, I can only number it. That's fine. It's a standard, so we'll get into this later on in our classes, but a standard access list is going to be, IP access list is going to be 1 through 99. So I'll just make this 62, and we're going to name it, or we're not going to name it because we can't name it, but access list 62, and I'll do a permit. IP any. Oh, it is by default it's any because it's any. Alright, yeah, and because, yeah, so here's the trick of it. Oh, but if I do I'm trying to get into access list mode, that's what I'm doing right now. I need to go into the extended access list. I'm thinking I can do that. I can't do names. So I'm going to do, let's do IP standard access list is 1300 to, so let's do 162. All right, access list 1620, and then I can't really change it. All right, if this was a router, it would have a it would have an access list mode. It would be shown up by doing config. In this case, there's standard and there's extended access list. It would tell you whether or not it's, but this is, and it would actually give you the name too. So. There's also a router mode, which we definitely won't have on this because it's a switch. So we have, you can do router, and then you're going in a RIP. It would say config router. All right, that's that right there. That's used to configure routing protocol. So config router is your switch. All right. All right, that's the first part. There's going to be a second part to this lecture as well, so I know it's a little confusing. Go through the lab, try to get yourself familiarized with the different forms of memory and some of the different modes of a switch. We'll get into routers and router modes down the road a little bit more. All right, so Cisco is an internet networking company that has many different products. Its core OS is iOS, although Nexus OS is taking over more and more market share, especially for core devices. iOS loads from iOS and NextOS, but we'll focus on iOS. Loads from flash to RAM. By default, the startup config loads from NVRAM. iOS has many modes, and it's critical to know which mode you're in and need to be in to get certain things done. Okay? All right, hopefully you got a little taste. I know it's a bit much at the beginning, but know these definitions. I think we have these concepts down. And work on practice 1.1, and we'll pick this up in topic 2. Let me exit preview mode. Topic 2 is not 100% up yet. I'm going to get that up today. But topic 2 will get you into the nuts and bolts of iOS. So we'll get a little bit more deeper in it. Hopefully get you more comfortable in it before we start moving on to other things like basic configurations. Okay? All right. I think I've gone on too long, so I'll talk to you later. Bye.